Hi dear students, welcome to all to another important session of Brainiacs classes. So we have a Brainiacs capsule today. So we are going to deal with another important topic, that is nucleophilic addition reaction. We have already seen electrophilic addition reactions in our previous videos. So those students who have missed out watching those, so you can consider subscribing Brainiacs classes and go to our playlist. There you can see Brainiacs capsule. In that you can see the electrophilic addition reaction, including the entire concept and the entire questions that is expected for NEET 2024. Okay, so today we are going to start with the next important type of reaction, that is nucleophilic addition reaction. So right now we are discussing addition reaction. We know that addition reactions are classified into three. What are they? Tell me, sir. One is electrophilic addition reaction. Then the attacking reagent is a nucleophile, or if it is attacking first, we say it is nucleophilic addition reaction. And finally we have one more, that is free radical addition reaction. So today we are going to deal with the concept of nucleophilic addition reaction. So what is the first point, sir? What is the first point with respect to that? So please understand the concept of nucleophilic addition reaction, or who gives this reaction. That is very, very important. The entire chapter, if you see, aldehydes and ketones are the compounds in your syllabus that give nucleophilic addition reaction. So whenever you have questions regarding aldehydes and ketones, always you should remember the mechanism with respect to NAR, that is nucleophilic addition reaction. So fundamentally, why it is called a nucleophilic addition reaction? I can say in this particular type of reaction, the nucleophile first do the attack on an electron deficient center. So a place where there is no necessary sufficient electrons. In that case, the nucleophile will donate its electrons to that particular site and forms a bond. And this is called as attack in organic chemistry. Okay. Now this is followed by what? This is followed by electrophile attacking the electron rich center. Since I know that the nucleophile attacks first, so we consider this type of reaction as nucleophilic. And also during this process, addition occurs. Okay, we know that it is happening in aldehydes and ketones. So we know that all aldehydes and ketones have carbonyl group. So after the nucleophilic addition reaction, the C double bond O becomes C single bond O, like that. So I can say it is a type of addition also. So that's the reason why we can call the reaction as nucleophilic addition reaction. Now we will try to see how this happens and what is its mechanism. So please see that. So in aldehydes and ketones, we know that there is a group that is called carbonyl group. So what is the peculiarity of this group? We know that here a double bond is present, but here the double bond is present between two different atoms. What are the two different atoms? One is carbon and other is an oxygen. And we know that they differ in electronegativity value. Here oxygen has 3.5 as the electronegativity value, whereas carbon has 2.4. And I can say the difference is somewhere 1.1. Okay, so whenever the electronegativity difference value is greater than 0.5, okay, we can say that there is sufficient polarity difference will be developed. So what will happen? The pi electrons that is present here will move towards the more electronegative atom, and this phenomenon is called polarization. So here in carbonyl group, this occurs without even the presence of an attacking reagent, or it occurs naturally due to electronegativity difference. So that is what shown here. You can see here the pi bond is getting polarized and the pi electrons are moving to the more electronegative oxygen atom. So what will happen? This pi electrons will move to here as a negative charge, and you can see a negative charge developed on the oxygen atom. Now during this process, what is happening, sir? I can easily say the oxygen, if you are looking around, you can see 8 electrons are present, 2, and here you can see 2 electrons here, another 2 electrons here, then another 2 electrons here, then another 2 electrons here. So I can say its octet is complete. But whenever you are referring to the carbon, if you see 2 electrons are here, another 2 are here, another 2 are here. So totally 6 electrons are there. So that means this carbon has its octet incomplete, but oxygen has its octet complete. Okay. Now I can say that if this is the situation, then tell me if you have an electrophile and a nucleophile is present. Think like this: electrophile and a nucleophile is present. I know that electrophile can move towards a negative charge and nucleophile can move towards a positive charge. But still, who will attack first? I can easily say the nucleophile will move towards the positive charge. Who will move towards the positive charge? Surely the nucleophile. Why? In order to attain stability. Please understand, in chemistry, all reactions are happening to make the system more stable fundamentally. Okay, so here we can say that around carbon atom there are only 6 electrons and around oxygen atom there are 8 electrons are present. Okay, hence the octet of oxygen is complete, which means oxygen is stable. However, the carbon atom has 6 electrons around it and its octet is incomplete, which means it is unstable. So what will happen? Who will attack first? Please remember, always the nucleophile will come near to the carbonyl group initially. This is common. This you can even by heart. Okay. Why? Because the carbon atom present here is unstable in nature due to octet, incomplete octet. Okay. So what nucleophile will do? Nucleophile will donate its pair of electrons to the vacant orbitals of carbon and it forms a bond like this. Okay, now you can see the octet of carbon is complete, but still the compound is charged because of the negative charge present in the oxygen atom. So what will happen in the next step? The electrophile will have a tendency to attack the negative charge to make the compound neutral, because always uncharged compound is more stable than a charged compound. So you will get an electrophile donating, taking its pair of electrons from the oxygen atom and forming a bond like this. This is how you are getting a nucleophilic addition product or NAR product. Understood? So first the nucleophile attacked, then the electrophile, and during the course of the reaction, what happened to the carbonyl group? The double bond gets converted to single bond. So that's the reason why we call this as an addition reaction, because addition of electrophile and nucleophile happened across the C double bond O. Understood? Very simple. So I can conclude saying that here the first attack occurs from the nucleophile as the carbon is unstable. This is followed by electrophile attacking the negative charge of oxygen. Since the nucleophile attacks first, we call this reaction as a nucleophilic reaction. And during this process, what happened? The double bond between the carbon and oxygen gets converted to single bond. So it is an addition reaction. So we can write the entire reaction as nucleophilic addition reaction. I hope you understood the concept. Clear? So I can say the characteristic reaction of aldehydes and ketones is nucleophilic addition reaction, which means 80% of its reaction would be following this particular mechanism. Clear? It's very easy. Now let's try to see how this is happening. Okay, so here this is a carbonate, it can be anything, an aldehyde or a ketone depending upon A and B. Now we know that if you take an aldehyde or a ketone, the carbon is in sp2 hybridized state. Correct? Because there is one sigma bond, so I can put here S, this P, another sigma bond here P. Pi bond will not take in hybridization. So spp, that is this carbon is in sp2 hybridized state. And we know that sp2 hybridization means its shape would be planar. So that means the whole compound is lying in a plane. You can think like doshakal. Correct? It is a single plane. Now what is happening? We know that the nucleophile will be approaching the positively charged carbon because the pi bond would polarize like this. Correct? So that is shown here. So what will happen? The nucleophile will attack the compound and the nucleophile will be hanging from this plane like this. You can see here it is hanging like this. Okay, now what happened? Now if you see the hybridization of the carbon, yes, P, another sigma bond P. So it is changing to sp3 hybridization, or I can say it is becoming a tetrahedral in nature. Whenever sp3 hybridization is there, it becomes tetrahedral intermediate is formed. So this can be a question during nucleophilic addition reaction. The hybridization of the carbon changes from sp2 to sp3 and the shape changes from planar to tetrahedral. Clear? So I can also say the first step would be a slow step. Why? Because the nucleophile needs to attack the carbon, and this depends upon how much amount of positive charge is developed on the carbon. This is very important, sir. That also give you the idea of reactivity, because more the amount of positive charge, more easily the nucleophile can attack. And this is the rate determining step. Why? Because it is a slow step. Okay, so how fast the nucleophile attacks the carbonyl group, that much fast you will get the product, because the second step is almost like an ionic reaction. You have a negative charge there, and here you have a positive charge electrophile. So it is almost like an ionic reaction, which would be very fast actually. So it cannot be the rate determining step. So in most of the case, I can say the rate determining step is the first step. So it depends upon if there is more positive charge on the carbon, more easily the nucleophile can attack. That means more easily it can form the product. But if there is less positive charge, then the nucleophile will not feel like, okay, I should go there and attack. So nucleophile needs to be invited so that more amount of positive charge should be developed here for the reaction to occur very fastly. Okay, I hope you understood. Okay, now this is my addition product. So you can see E forming a bond here. Finally, the hybridization of the carbon changing to sp3, and the whole carbon will now have a tetrahedral shape, or the compound have a tetrahedral shape is there. Clear? I hope you understood. Now I am giving a simple example. This can be an aldehyde or a ketone. Now it is reacting with the HCN. Very important reaction. So HCN will undergo heterolytic bond fission, forming H plus and Cn minus. Now I can easily say this is my nucleophile and this is my electrophile. Correct? Again, one more time I can write, this is my electrophile and this is my nucleophile. So who will attack? What will first what will happen? Any aldehyde or ketone, first you can do the polarization. Okay, so that negative charge will come here and positive charge will come here. Then the nucleophile will attack the positively charged carbon. So you will get an intermediate, tetrahedral intermediate, and this step is a slow step, and the next step would be very fast. Why? Because you have the electrophile H plus that will easily attack the O minus, and you are finally getting the product. So you can see here, whenever HCN addition is happening, you will get OH in one valency of the carbon and cyanide group in the other valency. And this type of compound where one carbon atom is holding both Cn and OH is called a cyanohydrin. So very important question, aldehyde or ketone on reaction with hydrogen cyanide. What is the nature of the product? It is a nucleophilic addition product, and the name of the product is cyanohydrin. Clear? Now I can easily say the rate of this nucleophilic addition reaction, it depends on what? The first step. So it depends on how the nucleophile can attack the positive charge on the carbonyl carbon. This in turn depends on what? This in turn depends upon the magnitude of the positive charge. If more the magnitude of the positive charge, more easily the nucleophile can attack and the reaction will complete very fast. Understood? So I hope you understood the concept. Now we will do the most important question based on this particular concept from this chapter. And please understand, this nucleophilic addition reaction related concept will be coming more on tomorrow, day after tomorrow, like that. Okay, we will cover all important questions from this particular area. Okay, so the question here is, all of you please go through the question. I will take a different color. Okay, yeah. So the question here is, the nucleophilic addition reaction will be most favored in means will occur very fast in, or will happen very quickly in, or which of the following compound will give a faster nucleophilic addition reaction. That is what the meaning of this question. Now we need to analyze. We are given 4 options. The first one is a ketone, because both side is an alkyl group. Second one is also a ketone. You can see both are alkyl group. And the third one is an aldehyde. Why? Because one side is only an alkyl group and other side is a H. Fourth one is also an aldehyde. One side is an H and other side is a hydrogen. Okay, one side is an alkyl group and other side is a hydrogen. Now let's see how to do this question. So let's start the analysis. So the first step we can do here is polarizing the carbonyl group. So carbonyl group will undergo polarization, negative charge will come here and positive charge will come here. Now we need to do the analysis. Listen students. Now here I need to think about whether this positive charge, magnitude of the positive charge, how it is going to get impacted because of the surrounding valency. One is a propyl group and other is a methyl group. I can easily say this propyl group, listen my dear students, I can easily say this propyl group is what actually, it is a plus I group. It is a plus I, inductive effect, plus I effect showing group. What does that mean? It will donate or it will push the electrons in this direction. So the electrons would be moving towards the positive charge. We know that plus I group will repel electrons. So that means away from each other. So that means electrons are moving towards the positive charge. So what will happen, sir? I can easily say negative charge coming to the positive means the magnitude of the positive charge decreases. So here also you can see CH3 group will push the electron in this direction. So I can say hold together, what is happening? Hold together, I can say here the magnitude of the positive charge. I can write the magnitude of positive charge is decreasing. Correct? It is decreasing. I can put 2 arrows, maybe 3 arrows if you need. Okay, it is decreasing very fast because one is a propyl group and another one is a methyl group, and which is also having plus I effect. I hope you understood. Now I am taking next one, acetone. Here also I am polarizing it first. Next I am seeing here also I can see methyl group here. Here also I can see methyl group. So both of them have plus I effect. So here also electron would be pulled in this direction. Correct? Pushed in this direction. So what will happen? The magnitude of the positive charge decreases. But you can see that which one will have a huge impact. I can say the magnitude of the positive charge decreases more in this one, the first one we have seen here. Why? Because I can say the plus I effect of a propyl group is more than the plus I effect of an ethyl group, which is more than plus I effect of a methyl group, CH3 group. This is the reason. So I can say here more easily the electron flow will happen. So I can easily say the first one is very less reactive compared to which one? Second one. Clear? I hope you understood. Now coming to the third one, you can say here also you have a propyl group is present. But fortunately we have here hydrogen, and we know that inductive effect of hydrogen is considered as 0. Okay, here the propyl group have plus I effect. So they will only push the electron in this direction. So what will happen, sir? The magnitude of the positive charge here also decreases, but to a lesser extent compared to the other one. So first one I have given 3 arrows. Here also magnitude is decreasing, but I can put 2 arrows. Why? Because from both sides the electrons are pushed towards the central carbon atom. And here the propyl group is only pushing from one direction. Okay, so here also the magnitude of the charge, or we can say the positive charge, is decreasing. Okay, now let's see the last one. If you see, you have only one methyl group, and this is also an aldehyde, and it is pushing the electron in this direction. So here also the magnitude of the positive charge is decreasing, but very less compared to this one. Maybe I can make it more clear. I will put 4 arrows here, making the charge decreases very fast. Here the charge is also decreasing. I am putting 3 arrows. The magnitude of the positive charge is decreasing. Okay, and here I can put maybe 2 arrows. Okay, and the last one I can put only single arrow because it is decreasing very less. Here this also have plus I effect. Clear? But now I can say comparing these four I can say the relatively a good reactive one is acetaldehyde because its positive charge is decreasing very less. So I know that the reactivity is directly proportional to what? Tell me, sir. Again, please remember the magnitude of positive charge. The magnitude of positive charge. If you have more positive charge out there, more easily the nucleophile can attack. So here CH3 is decreasing this positive charge in a very less way. That's why here I can say the nucleophile can find some positive charge here and it can attack. The nucleophile can attack this positive charge. Clear? I hope you are understanding. So it's a relative comparison we are doing. So here I have tried to put these things in an order. So when the reactivity would be increased, you can easily say whenever you have two -I groups are connected. So what will happen? The electron will flow in this direction. Here also the electron will flow in this direction. So what will happen? When electrons are flowing in this direction, the magnitude of the positive charge increases here very fast. And I can say such an aldehyde would be more reactive, or it would be more reactive, such compounds. And if you see here only one -I group is there and one is a hydrogen. Then I can say here also electrons are flowing in this direction only. Okay, that will increase the magnitude of the positive charge. Okay, so here also the reactivity increases, but the first one would be more reactive, or I can say more the number of -I groups, the reactivity of aldehyde and ketone towards NAR would be very high. Here only one -I group is there. Here if you see one -I group and one +I group is there. So I can say this will pull the electron in this direction, increasing the magnitude of the positive charge, but this is pushing the electron in this direction towards the positive charge, and the magnitude of the positive charge is decreasing. So somehow it is balanced. Now in the next case, you can see +I group alone is connected. That means it is pushing the electron in this direction, and what will happen? The magnitude of the positive charge decreases here. Here it is balanced, and in the last one you can see two +I groups are connected. So both are pushing the electron in this direction, sir. And what will happen? The magnitude of the positive charge decreases very fast, or it will, as a result, the nucleophile will not even want to come near and attack. Okay, so this is the fundamental, and you can also remember one more concept. For example, in addition to +I group, suppose resonance is present. You are given a compound with a resonance here, then what will happen? I can think like, suppose a benzene is connected here. Still I can say the positive charge may enter into resonance with this benzene ring, and when nucleophile comes here, there is no positive charge. So in that case also the reactivity would be very less. Even some books says that if you have a compound like this is benzophenone. Which is I can say this will not even undergo nucleophilic addition reaction. There are two reasons. One is the positive charge developed here can enter into resonance in this ring or this ring. Or even I can say the nucleophile will not try to go here. Why? Because of the repulsion of the negative charge by the pi bond present here. Understood? So even I can say benzophenone will rarely undergo nucleophilic addition reaction, or it is considered as the least reactive carbonyl group, or least reactive ketone. Okay. So generally speaking, I can say aldehydes are more reactive than ketones. Why? Because aldehyde have only one alkyl group connected to carbonyl group. Okay, but when I am taking a ketone, it have two alkyl group connected, but it is relatively depends upon whether this alkyl group has -I group or not. So I cannot completely say that always aldehydes are more reactive than ketones. It depends actually. Okay, I hope you are understanding my point, because if both these alkyl group have fluorine atom, then I can easily say both are -I groups. Surely the positive charge present here increases and its reactivity is also increasing. So generally I can say, for example, if you are comparing CH3CHO, okay, CH3CHO, with you are comparing this with, let me say, acetone, CH3COCH3. Then I can say here aldehyde is more reactive than ketone because only one CH3 group, here two CH3 group is making it, decreasing the magnitude of positive charge. I hope you understood. Okay, very important. Now, so tell me, sir, what is the answer for this question? So I can say from the given options, the most favored or the very fastly it will happen in option 4 because it has only one CH3 group. That's why its magnitude of the positive charge is decreasing at a very lower rate compared to the other options given below. Okay. Yeah, I hope you understood the concept. Now let's try the next question here. So, which one is most reactive towards nucleophilic addition reaction? Almost similar question. But here I have given benzene ring, okay, along with some substituents. Now let's analyze. So here you can see an aldehyde is given. So you have a benzene ring here. You have a benzene ring here. Now next step, what you need to do? You do the polarization. So you have the positive charge. I can easily say this positive charge will enter into resonance with the benzene ring, and when the nucleophile is trying to come to the positive charge already went into somewhere. So I can say that the reactivity would be comparatively low here. Now in the next one, you can see here also benzene ring is present. So I can say this polarizes again in this direction. Positive charge will come here, and I can easily say this will enter into resonance with the benzene. Along with that, here you can see a plus I group is being connected, and this will push the electron towards this direction. So it will also decrease the magnitude of the positive charge. So here I can say the reactivity would be decreased very fast or less reactive compared to first one. Here reactivity is decreasing. Reactivity only I am putting here. Okay. Reactivity is decreasing. Why? Because the charge density is decreasing here. Okay. But in the second case, it can enter into resonance. Also, the CH3 is also decreasing the magnitude of the positive charge. And in the third one, you can see a CH3 group is being connected here. CH3 group is being connected. So what will happen, sir? CH3 group have plus I effect. So it will donate its electron through the sigma bond. It is coming like this, you can see, and electrons will reach here and decrease the magnitude of the positive charge. And also this positive charge can enter into resonance with the benzene ring. Okay, and when positive charge comes at the para position, the CH3 group will enter into hyperconjugation, making this system, or I can say the positive charge would be more stabilized here. It will not try to come to this particular spot very often because more resonating structures are there due to hyperconjugation given by CH3. So I can say that here the reactivity would be much lower. Okay, now in the last case, you can see NO2 group is being connected. Now comes the difference. When NO2 group is being connected, we know that NO2 is a minus I group and a minus M group. So what will happen, sir? Through the sigma bond, electron will flow towards the NO2 group. So what will happen because of that? When electron is flowing in this direction, the magnitude of the positive charge here increases. But still you can ask me, sir, this positive charge will enter into resonance with the benzene ring. Yes. So comparatively the reactivity is less, but when I am comparing with the other three compounds, I can say here the magnitude of the positive charge is little more high because the electrons are flowing in this direction. So I can say from the given options, this one would be the most reactive in nature because the magnitude of the positive charge is increasing. The magnitude of the positive charge increases, so the nucleophile can easily attack the positive charge. Understood? And we know the first step is the rate determining step. So my answer here would be which one, sir? Which is most reactive towards nucleophilic addition? Fourth one. So I can easily say whenever you have a benzene ring and if there is a minus M or minus I group is being connected, surely the reactivity, the nucleophilic addition reaction rate would increase, especially if they are connected at ortho-para positions. Okay, NAR rate would increase. But if plus some, but if plus some or a plus I group is being connected, please understand, plus some or a plus I rate group is connected, I can say the nucleophilic addition reaction rate would decrease. Why? Because these guys will donate electrons and decrease the magnitude of the charge. Hope you understood. Okay, yeah. Now let's go with the last question for the day, and I hope you can now easily attend this question and tell me the answer. So the order of reactivity of phenyl magnesium bromide, this is a Grignard reagent, with the following compound is. Again, I know it's an aldehyde or a ketone. Its reaction with the Grignard reagent again follows the mechanism, that is nucleophilic addition reaction. So I can easily say, compare the reactivity of these three and you can say which one will react very fast. So we will do that now. So the first one, again, it's an aldehyde. Again, I can say CH3 group is present and the CH3 group have plus I effect and it will push the electron towards the central carbon. And I can say comparatively its reactivity would be lesser because plus I group is there. But when I am looking at the other one, you can see two CH3 groups are being connected here. How many? 2. Both of them have plus I effect. So electrons are pulled towards the central carbon from both directions. So here the magnitude of the positive charge decreases very fast compared to the first one. So comparatively, first and second, the first one will be more reactive, I can say. In the last one, I told it's a benzophenone. I can easily say this positive charge will enter into resonance with this benzene ring or with even this benzene ring. So when nucleophile cannot even approach this particular compound. Why? Because there is lot of pi electrons present here, lot of pi electrons. What these guys will do, it will repel the incoming nucleophile. So nucleophile will not even find easy to come near, and even if it is coming, it will not find the positive charge. So I can say the very less reactive. So I can say the order will be the 1 is more reactive than 2 and 2 is more reactive than 3. Correct? So my order would be here what, sir? What would be the order of reactivity? Answer would be option 1 would be my correct answer, because 1 is more reactive, then 2, then 3. Now we can also learn, as part of our curiosity, we can also learn how these compounds react with the Grignard reagent. Okay, that's very important reaction. So I'm explaining that also for your understanding. So here the first step, you know, every time it is similar, the carbonyl group will undergo polarization. By heart this, for aldehydes and ketones, the first step is always the polarization happens. Why? Because electronegativity difference. Now next, who will come, sir? Now we need to understand who is the nucleophile from this particular reagent. We know that magnesium is an electropositive element and here carbon is present. So carbon and magnesium, who is more electropositive? Magnesium. So electropositive element will repel the electron towards electronegative atom. So carbon is more electronegative. So when the bond breaks, negative charge will come with the benzene and positive charge will come with the magnesium. So we know that negative charged species is my nucleophile. So this will attack my positive charge. Okay, and you will get the first tetrahedral intermediate like this. In the next step, the electrophile here is MgBr plus. So that will attack the compound at this particular position. And here, this is my final product. This is my NAR product. But this is not a relevant product. So if you do a hydrolysis of this, we can convert this to an alcohol. So usually questions comes like this. So first you will get this product A, then they will say followed by hydrolysis. Followed by hydrolysis, what will happen? We know that OH is a strong nucleophile. So that will attract the highly electropositive MgBr towards it. So it will form MgOHBr first. Then you have oxygen with a negative charge here. Why? Because this pair of electrons while breaking the bond will move towards oxygen. And because of that, what will happen? H plus will attack the oxygen and you will get an alcohol. And what sort of an alcohol is this? I can easily say this is a 2-degree alcohol. Why? Because this carbon is connected to 2 other carbon atoms. Clear? Now similarly, you can do the same things for acetone also. Acetone, here it will undergo polarization, this will undergo breakage, nucleophile is there, electrophile is there, so it will attack, a nucleophile first will attack, then you will get a tetrahedral intermediate, then MgBr will attack, same thing, then followed by hydrolysis. Now you are getting an alcohol. You can see here this alcohol is a 3-degree alcohol. So you can think one thing. Here Grignard reagent, starting Grignard reagent has only, how, if you see how many carbon atoms are there, you can see one carbon atom. Due to Grignard reagent it is coming, and if it is aldehyde you will get one carbon due to aldehyde. Now if it is ketone you will get two carbon due to ketone and one carbon due to Grignard reagent. So you can easily say whenever a ketone is taken you will always get a tertiary alcohol. Why? Because you will always get two alkyl groups from the ketone and one from the Grignard reagent, because this carbon is connected to one carbon of Grignard reagent. So always a 3-degree alcohol comes with a ketone. Okay, now you can see the last one where I have taken benzophenone. So I told this will rarely undergo reaction. It's very difficult. Here also the nucleophile is also very bulky and bigger one. So it will find very difficult to come near to this carbon and undergo reaction. So I can say this is a very rare reaction, very rare reaction. And you will get an alcohol like this. Here also this alcohol, you see it's a tertiary alcohol because the starting compound is a ketone. Benzophenone, it's a ketone. So what is the summary, sir? I hope you are taking screenshots. Any doubt? You can all take screenshots very easily. I have neatly kept for you guys only. So if you have any doubt, feel free to ask in the doubt comment box. Don't feel any bad. And my summary is very important for today. Summary is, whenever you are taking formaldehyde, it's a special case because it does not have any formaldehyde. If I am taking, there is no carbon atom connected to the carbonyl group. Okay, so there will be only one carbon atom given by the Grignard reagent. So that's the reason why primary alcohol you are getting. And if you take any other aldehyde means there will be one more carbon other than CHO group. One more carbon other than CHO group. So that along with the Grignard's reagent carbon, so these two carbon will come connected to the alcoholic this carbon. So you will get what? 2nd degree alcohol. And if you take any ketone, I have shown you with the Grignard reagent, already two carbons are there in the ketone along with the carbonyl carbon. Please understand that. So totally 3 carbon would be there, but these 2 carbons I am considering. Along with the carbon from the Grignard reagent will give you a 3-degree alcohol. So please remember, formaldehyde will give you with the Grignard reagent followed by hydrolysis 1-degree alcohol. The mechanism is nucleophilic addition reaction followed by hydrolysis. Please remember, if hydrolysis is not there, alcohol will not be formed. Next one, any other aldehyde will give you 2-degree alcohol. Any ketone will give you 3-degree alcohol. I hope you understood today's session. Tomorrow we will continue with other important reactions. That means nucleophilic addition reactions only. Then you can put all your doubts in the comment box. Thank you. Thank you.